Arkin on Twitter if you're so inclined. I am historically coming from a development background, so I started in the industry, 12 years ago, doing logistics systems for the United States Air Force in uniform. Then I moved into security whenever some general's information got leaked out from a breach. They kind of thought maybe, hey, we should start looking into the software security thing, and that's kind of where I stepped in. So I'm a big software security nerd, and that's kind of important, that transition from development to software security and then into what we're going to be discussing today. So history has a lot to do with it, as well as kind of the skills that get picked up along the line. So important for me to understand as well is a little bit of who are you. So just a quick show of hands. How many developers do we have in the room? That's awesome. Developers at a security conference is awesome. DevOps. Anybody practicing DevOps? Want to practice DevOps? DevOps keeps them up at night. They're terrified of DevOps. Everybody know what I mean when I say DevOps. Okay, great. Security practitioners. Oh, hey. I think I saw some overlap in hands, which is even better. So from the security people, just drilling down a little bit. Whenever we talk about security, that can be a pretty nebulous term. Anybody dealing with actual like source code review level application security? Great, that's awesome. Network security folks? Okay, and then platform, I'm assuming, is associated with that. What about like audit? No auditors. Excellent. Oh, one. Sorry, I wasn't about to badmouth auditors. I promise. Great. And then business and manager side of the house. Just kind of want to get an understanding, because I'm probably going to put those folks to sleep. Okay, good. So let's talk a little bit about modern software development lifecycle, really briefly. So development has kind of moved over the course of the years from a very big, long process of waterfall, right, where we have a very long design phase and a very long code phase and testing phase into very small incremental steps where each little bit of change in the code can actually be a deployment, and that deployment might happen in 1 to 2 weeks, maybe even daily, right? So code is moving and going into production systems in a very short order these days. So that's kind of a goal of modern SDLC, is to have those very short delivery schedules, and it's seen as a big benefit. Anybody doing security reviews in the room, how long is your typical code release for your organizations? 1 week, 2 weeks, months?
Varies by group.
Varies by group, yeah. There we go. Especially if you're an enterprise, right? You're going to have a lot of different answers to that question. Well, then I guess quick show of hands. Who's dealing with a lot of agile at this point? Okay, that's a pretty good representation. If an agile sprint takes 2 weeks, how long does a security review take for you typically? I'm sorry? Okay, yeah, there we go. There's one answer.
0.
Yeah, so if you were to do a comprehensive security review, do you think you could pack it into 2 weeks and really have an understanding of your applications? Yeah, that's a problem, huh? Especially if you're doing it manually. Manual analysis of source code, manual penetration testing, these things are pretty intense, right? They can take some time. And trying to cram that into a 2-week sprint is a challenge. So we're gonna visit that and touch on that repeatedly, I promise. Some other principles of the modern SDLC is the increase in feedback, right? So we're generating our code and we're getting relatively close to immediate feedback. We do peer reviews potentially. We have some system that takes our code and tests it for us and lets us know if our tests are passing or failing. And that feedback helps to speed the process along so that we're not making maybe some simple mistakes that could be fixed before they become bigger mistakes down the road. And we're going to leverage that a lot in the rest of this discussion, and hopefully what we're going to take back to our respective organizations and put into practice with some continuous integration, delivery, and deployment. One final point here. So the reducing scope of a deployment. So as the modern development life cycles have kind of evolved, we've gone from creating the system to creating components of a system. So whenever we create a component of a system, each deployment might only focus on one very small part of the overall software. And that is a bit of a benefit to security practitioners surprisingly enough, because of one small change. While it may have impact across the entire landscape, it's probably relatively easy to isolate and then fix. Okay, so what does CICD squared success look like? And I want to clarify that really quickly because most people would say CICD or CD. So when I say CICD, I'm talking about two different CDs. There's continuous integration, continuous delivery, and continuous deployment. Okay, so continuous integration, how many folks know the word Jenkins? Awesome. Relative familiarity with Jenkins? Cool. Travis CI users? Anybody using some of the more cloud-based CI solutions? No? So mostly Jenkins, Hudson. Any other outliers? There are enough tools to fill this room. TeamCity, great. Hey, JetBrains folks, I'm with you there. Cool. So those CI tools have been more traditionally used even in waterfall development, right, to perform unit testing, functional testing, integration testing. So we can leverage some of that technology, and we'll see that in just a few slides, to help us with security as well. But that's the more traditional kind of security testing, or I'm sorry, just software testing that we're used to seeing in a development lifecycle. What some of the new concepts or newer concepts are kind of move into that continuous delivery and deployment space. So I look at continuous delivery as a prerequisite to continuous deployment. Delivery is packaging up our code, whatever's going to run, whatever the system is, and that might be multiple components, microservices, architectures, if you're using those, service-oriented architectures, period. Being able to package those into a deployable object is the delivery bit. So maybe we can take that deliverable artifact, whatever that is, jar for those folks in Java land. Maybe anybody using containerization in the room? Okay, how many folks have heard the word Docker in the room? Okay, snickering, yes, good. So that's another more modern option. Great. Yeah, so the delivery bit is making sure that we have something that we could then take and make a decision around if that's going to go into production. And going into production, pushing that out to a system where other folks are going to have access to it is the continuous deployment. So making sure that those three things are very distinct, you have their own definitions, is important up front. So a good CI/CD toolchain is going to help us write secure code rather than to have us as security practitioners hinder the development of code. And what I mean by that is traditionally, how many folks like to hear that they're being audited for anything, right? Everybody ready for tax season? Who's ready for their audit, right? Nobody likes that. So security is, as a group or as a people, have a bit of an adversarial relationship at times with developers. And we need to start avoiding that. And we can do it really, leverage CI/CD technologies to do that really well. Because we can help the developers earlier on to actually produce secure, good code that's not going to expose that system to vulnerabilities in the future. So we want to make sure that we're building security in to systems that developers are already used to, first and foremost. If we have Jenkins users and TeamCity users in the room today, right? If I say, okay, that's great, I'm from the security group, and we've decided that you don't know what you're talking about, and we're going to use Travis CI for everything. All right, we're moving to a new platform. How many of you that are developers are on board as soon as I say that? No hands. Okay, that's good. Sanity is preserved. Nobody's just not listening and raising when they hear a question. Like it. Okay. So that's good, right? So familiarity with the tools is going to help us get in the door with the developers, something they already trust, and we can then use those technologies really well to help the developers. So really important thing, we want to build security in to what's there when we can, and we can introduce some other components, but we don't want to overwrite everything. That tends to not be so hot. So that's going to help us create that culture of security that doesn't inhibit the workflow. So if we have security vulnerabilities in the room, once again, quick show of hands, how many of your organizations allow security to be a production deployment gate? We have a security failure at some point, we're not going to production. Okay. How many of you do that with some scale of vulnerability impact level, let's say? Not quite as many hands. That's okay. So some organizations don't have much of a risk appetite, and they'll say, if we have any vulnerabilities, we're not going to production. which tends to grow that adversarial relationship a bit and tends to not fit very well with a lot of the more modern development methodologies like Agile, like DevOps, only because they're used to rapid iterations and pushing things out, right? We might not be able to get a review in before their delivery schedule has arrived, and if we can't do that review and they can't get their answer, whether or not they can deploy, they're probably going to get a little antsy. I would, if my deadline was at the in the hands and at the mercy of someone else entirely. So another thing we need to kind of keep in the back of our minds when considering moving to a continuous integration delivery and deployment pipeline is shifting that mindset of we have security problems and we can't go to production, or we need to wait for a security review before we go to production, into something that's a little bit more, we've got some showstoppers. We've identified some security vulnerabilities or categories of vulnerabilities that keep everybody up at night, and we can't go to production with those. However, some of these other vulnerabilities, some of these other categories and classifications, maybe we can let those slide for a while. So let me couch that this way. How many folks in the room are sure that they're not pushing any code to production with security vulnerabilities in them? I promise I won't publicly call you a liar, but I might imply it. Okay? Yeah, so nobody's sure, right? So whenever organizations come back to me and say, well, we can't push this code to production, what if there's a vulnerability? The answer is, typically for me anyway, look, you are already, probably daily, pushing code to production that has vulnerabilities in it. You just don't know it yet. So knowing it gives us the path to fixing it. It doesn't necessarily mean that we have to know about it before the code goes into production. In some cases, if you're handling some mission-critical systems, maybe that's security is going to take the forefront. But typically, security is going to be hurting the process more if we're hurting the business. That's how you tend to make enemies inside the organization. So that's well and good from a philosophical perspective, and we could certainly debate that for quite some time. But let's talk a little bit more about the technical perspective and how we can make some of these things happen with the tools that are out there today. So what is this tool chain that we're talking about, right? CICD, DevOps, Agile, all these big buzzwords that attracted such a huge audience today really rely on speed, right? We need to be able to do things very quickly, very iteratively. We get code built in short order, it needs to be tested in even shorter order, and it needs to go out to production, out to our users as soon as possible. Okay? So to do that, what we need is a way to automate a lot of tasks. We need to have testing to ensure the quality of our code relatively close to fully automated. For security people, it's going to be the exact same type of thing, right? We need to have some security checks in place that are automated because doing a manual review is once again very, very difficult. And that it takes a lot of time, and that might not fit in with the release schedules, the release cycles. So the tool chain is going to be composed of bits that help us test our code for functionality, for security, do some sniff tests, right? So able to package that code, and then we're able to make decisions about the health of that code, whether it be, once again, from a functional perspective or from the security perspective, and then push that code out to a deployment environment. This is a wall of text, but it's to get the point across that there's a ton of stuff out there to perform all of these different activities, right? So you might have Jenkins being used for many different steps in this chain. You might have different version control systems, Git, Mercurial, SVN, CVS, right? Anybody still using SVN in the room? Is everybody on Git? No? Okay, something else. Anybody on Git? Okay, cool. That's interesting. Great. And then you have things like artifact management, test environment automation. Effectively, what we have, once again, all those tools, they're all disparate things. They're all produced by different shops. You might have mismatched gear all over the place, right? We need to take all of those tools that are out there and be able to get them working together into a seamless delivery pipeline, right? It's also extremely important that we inject security into the right places in that pipeline so that we can not necessarily stop the process, but at least inform the process as often as possible and whenever we can to get the right effect. So this is an example view of a pipeline or of the tool chain itself. So we have multiple steps. This kind of, unfortunately, looks a little waterfall. But if we just take that and turn it into a circle instead of a line, that's agile, right? So we're good. So we've got code development. We've got our code commits, or version control. We have to build our code in some way, shape, or form, unless we're using some more dynamic languages. Then we have to test our code, make sure that it's functioning. We'll have unit tests, functional tests, integration tests. And then we can make a decision about whether or not the code is healthy. And then we can push that into a pre-release environment and then out into production. So where we inject security is at almost every single step along the line here, right? And we can do many different things. So there's some code checking or static analysis. When I say static analysis, how many folks are employing static analysis? How many folks are familiar with the term? Okay, great. So we've got a pretty good swath. If we throw out some more of the commercial tools like Fortify, AppScan Source Edition, maybe that'll pique some other folks' interest. There are also open source options, which obviously we'll talk a little bit more about today. So we can have static analysis occurring in the IDEs, potentially, if there's an IDE plugin for the tooling that we decide to go with. We can have a deeper level of static analysis, or maybe a more lengthy scan duration occur after the code gets committed to our version control systems, or into our build management system. As part of the unit tests, this is another interesting place where we can actually inject some security that goes beyond static analysis. So one of the things that I found worked really well with a lot of my clients over the course of the past 2 years is they were doing very rapid deployment schedules. They found that static analysis tools weren't really covering their code bases very well. It wasn't giving them a lot of security insight. Maybe it was giving formatting and some superficial feedback about their code, which they could then change automatically, but the security was lacking. And they were able to find things really well with penetration testing and dynamic analysis. So, but they still wanted earlier answers. They wanted earlier alerts that they're having problems with their the security of their code. So one of the things that they did, and I helped them to do, is create some more unit functional and integration test strategies that included security. So we'd have security unit tests. So instead of just testing for our use cases, we were also looking at use cases. Can we assert that if somebody sends us a cross-site scripting payload, our system knows how to handle it and doesn't render it back to the browser and ultimately affect our users? If we do it with the same thing, SQL injection, does it affect our database? So doing that at the unit tests, and then also applying some concept of a security regression test. So once again, nobody's deploying code that has 0 vulnerabilities, right? We might not know about them, but it's probably vulnerable in some way, shape, or form. So if we find those things, whether it be through some other form of testing or out in production, somebody identifies this vulnerability and lets us know about it, making sure that we don't reintroduce the exact same thing at some point in the code cycle is going to be pretty important. So that's where that concept of a security regression test can come into play. So breaking down and getting into these things a little more deeply. In code development, right, everyone's using some sort of IDE. If anybody says Emacs at this point, I will kindly ask you to silently stand. No, I'm just joking. It's a perfectly fine tool. So IDEs, Eclipse, NetBeans, JetBrains, Visual Studio, whatever it is, there tend to be a lot of plugins that we can use for those IDEs. They're going to give us some introspection into our code. And while they may be not historically security-oriented, there is good news. And it's not on the next slide. So the good news is that a lot of these tools are extensible, right? If you're a developer, maybe you get it in your head that you'd like to make those improvements yourself to the engines, to have the engine itself be able to find some security vulnerabilities. Depending on the tool, it may already have an engine that's capable of finding data flow, let's say, through the application, and we just need to write some custom rules or some identifiers for that tool to be able to find our security vulnerabilities. And we'll talk about that in just a minute when we get there. On the commit side, we already talked about the version control systems that are available and who's using what. For build automation, do we have any Gradle users in the room? That tends to be the most outlying. Thank you. So, I've got a friend that's a principal engineer over there, so it's good to see at least somebody's doing it. Maven, Ant folks in the room? Yeah? Okay. Anybody just God forbid, make files? No? Okay, good. Yes, there are any number of options there as well. One thing to note here is there might not be a direct plugin to these systems, not something that's packaged up as, oh, this is a Maven plugin, and will work right out of the box with your build system. But a lot of the tools that we can talk about are going to be able to be driven from the command line, right? And as soon as you can drive something from the command line, any tool from the command line, you can pretty much build it into any tool chain that you want. So long as we can give it commands, tell it how to execute, and then take its output and understand that output and transform it if need be, we can start building these APIs between each tool, right, and teaching them how to integrate and how to flow through one another, which is the big principle we want to take away from this. So some SAST-related tools. So we uncover a couple of blocks down here. Find bugs, PMD, those names ringing any bells with folks in the room? Those are some open source tools for Java in particular. PMD has some more coverage than Java, but mainly we see these used in Java shops. So these tools are great because they do static analysis already, and you can write custom rules for them. So if you don't have the budget or the desire or whatever that your reasoning is to go out and get a commercial tool like HP Fortify or IBM AppScan Source Edition, maybe the coverage isn't what you want, you can actually write your own custom rules for these types of tools. Codescope's Secure Assist is another one up there on the commercial side. So you have many commercial options, many open source options. Whenever we talk about free open source software, how many folks are using free open source software? I assume every hand in the room is going to go up. Okay, not all, but that's surprising. So when we say free open source software, is using open source software free? So a lot of head shaking no. Why is that? Anybody?
Still a license attached to it.
Yeah. Okay. So that's one thing. We might have some constraints about how we can use it if we can re-implement that code in any way. Anybody else, operationally speaking? I'm sorry. Yeah, support. Support and maintenance, right? So we can write custom rules for all of these tools inside of our organization. But that takes time, and time is proverbially money, right? So there is a cost associated with any free tool as well. And that cost may just be the time that it takes to write the rules. But it's probably also going to include time to research how to write the rules for the tools specifically in their nomenclature. Figuring out what rules to write in the first place, right? How do we best identify these vulnerabilities in our code, and how do we then tell the tool how to find it? So there's a cost related there. So make sure that you're balancing that whenever you're making your decisions. Once again, it's totally possible to build a freely open source tool chain from end to end using any number of these tools in tandem, but you're still going to be incurring some cost in that regard. It's not entirely free. In the sense of money. So on the dynamic analysis side, there are also a number of options, right? You've got OWASP, ZAP, you've got Arachnid Scanner, and then the commercial options with AppScan Standard, WebInspect, really any number of options for both open source and for commercial, but these tend to be the heaviest hitters. Okay, and that's not where I want to go next. So We've talked quite a bit about the tooling itself and the freely open source available options. One thing that we can talk about very briefly here as well is how do the CICD kind of swim lanes fall over this graph? And obviously with continuous integration, we're going to be looking at that middle pipe of the three stacked on top of one another. This is where our Jenkins of the world live. And here's where our unit tests are going to be run, maybe our static analysis tools. Anybody know the core differentiation between static analysis and dynamic analysis tools and what they require?
Static is usually analyzing code, whereas dynamic is usually analyzing it from an external source, like a black box test.
Yep. Yeah, so we need a runtime for dynamic analysis to work. So up to the CI level, we can do everything very statically. We can perform static analysis with any of the tools that we listed out, and we can get our results and make some decisions there. The next bit of it really relies on continuous delivery. If we want to do dynamic analysis, we need something that runs. So we need to be able to deliver our code in a runnable package. So once we've hit the continuous delivery phase, then we can actually start automating dynamic analysis using some of the tools that we talked about earlier as well. I built a reference architecture to go along with some of these concepts a while back using Docker containers for the application, so we can get to the static analysis point in Jenkins. Jenkins knows how to run our unit tests, our static analysis, and then it knows how to package our application inside of a container and deploy that container to QA environments. And another kind of key product or key feature that we look for in CD pipelines is service discovery. Anybody using service discovery tools today in the room? Okay, so anybody heard of HashiCorp? Vagrant. Okay, yeah, I hear laughter. So Vagrant is HashiCorp's probably most popular product. They also have another tool called Console that's gaining some traction out in the world. And what Console does is that service discovery end. So service discovery lets us say we push a container out, or we push a service out to a running machine. And then that machine knows to announce to the service discovery system, hey, this is the service that I am. I live at this IP address. I live at this port, right? And then we can use that knowledge from our dynamic analysis tools or from our penetration testing workflow to go out and say, where can I find the service that I need to test? And it will tell us the version, the location, the port, right? Everything that we need to know to test that application using dynamic analysis tools or penetration testing. We can glean that knowledge from the service discovery and automatically kick that off. So then what we've ended up with at this point is a bunch of results from static analysis, a bunch of results from our unit tests, our functional tests, our integration tests, and results from dynamic analysis. But there's no real way to tie that all together. So typically unfortunately, this is just kind of the state of the industry, one of the things that I've seen most of my clients doing is either building some custom decision code or scripting at the end of all these steps, and then pooling that data and saying, okay, once again, if we have critical findings, stop the presses. If we have injection attacks, we can't go to production. But if we have, let's think of a good one. Anybody of our static analysis users in the room, what is your favorite finding to pick on? I've got mine. I'm just curious what other people's are. How many of you are actually looking at the results from your static analysis tools? I don't mean that as a dig. I just mean how many of you actually have that as a requirement of your job. Okay, so what's a good one that you've seen that you just every time you see it you're like, man, no way.
Oh, we just started using.
Okay, that's perfectly fine. So one of the ones that I tend to see a lot is like hard-coded passwords. So are hard-coded passwords a problem? Yeah, they're a big problem, right? Especially if you're publicly housing your code. Problems on some of the more public Git repositories a few years back where people's like private keys were just like hanging out in their repositories that anybody could access. Maybe a bit of a problem. So hard-coded passwords are a hard thing, right? It's a bad thing that we don't want to have to go into our production systems. However, finding hard-coded passwords statically is really tough, right? How do we do that? Anybody know what a semantic analysis engine is from static security perspective, static analysis perspective? It's grep, right? It's grep. Let's just call it what it is. So we've got regular expressions running. How do we look for passwords with a regular expression? We probably look for things like pass, PWD, which tend to be reserved words in languages, right? Or portions of scripts. These are common letter combinations that might show up. So we can have this huge amount of false positive findings coming out of our tools. We might not want to stop the presses for something like that. We might still, depending on the severity of it and how confident we are in those results. But the key thing to keep in mind is that it's going to be our confidence in those results. So it's a function of the risk, how severe is this vulnerability going to be to us, as well as a function of how confident are we in this finding. So whenever you're doing things in an automated fashion, you have to make sure that you're not shouting out that the sky is falling all the time. Nobody's going to listen anymore. They're going to find ways around it, even if it is automated. They're going to find an exception process and not use it. So that is a bit of the lessons learned, and I like to leave as much time as possible, which I think we've done here, for questions and discussion, because I think this is pretty valuable. So anybody have any questions? Let's start with that. Okay. So everybody is currently using continuous integration technology. We've had a number of hands for Jenkins and TeamCity. What about continuous delivery? How many folks have made that step? Continuous deployment, skipping delivery. So nobody's pushing their code directly to a live system from CI. Okay, that's perfectly fine, and it's still growing. It's a rapidly growing trend, but it's certainly not there yet. If you were to take anything away from today and go implement that directly into your CI system, what would you do? Let's say from a static analysis perspective, what are some of the things that you are doing currently?
I think for us, we're going to probably look at something like Breakman and do that as a build step.
Yeah, great.
And try to come up with some policies about, like you said, we reach some certain threshold, we'll fail to build.
Very cool. So big Ruby shop?
Yeah, we're just getting into that. Yeah, our latest project is all Ruby with Rails. Okay.
Yeah, so Breakman is certainly an admirable option. In fact, if you've been around all day, you've probably met one of the guys, developers that was pretty instrumental in its growth, Aaron Bedros, another presenter here today. So yeah, that's a very solid choice, good option. Anybody else have anything that they're taking away or planning on doing that they'd be interested in maybe learning more about, talking about while we have time to vamp? No? Okay. Well, I'm going to stick around for a couple of minutes. If anybody has any questions that they'd like to address more privately, I'd love to chat. Thanks everyone for coming out. Once again, if you want to look me up after this, if anything comes to you, you can always hit me up on Twitter. I'd be happy to respond. I guess you could also email me at my company email, but I mean, come on, what are we, cavemen? I'll put some business cards out here if anybody's interested in following up later. But thanks a lot again. Hope you had something interesting to